IsoChronic City is an urban response to the socio-economic problems caused by population growth, lack of infrastructure, and haphazard development as a consequence of urbanization. London has undergone counter-urbanization and re-urbanization since 1900s. The recent population decline in the city core is a result of urban decay. Spatial signatures are created based on parameters such as population density, land use, accessibility, deprivation, and connectivity. The dense urban signature is selected as it is predominantly residential in nature with access to jobs and services. The impact of the COVID-19 pandemic is studied, and a spiking increment in the usage of green spaces and reduction of retail and commercial footfall is observed as the hectic lives of the commuter group takes a backseat. The project aims to answer the question, what reurbanization of cities will look like as they start to emerge from the COVID-19 crisis. The design intends to achieve a sustainable, inclusive, and accessible city which repeats itself at regular intervals. A 15-minute neighborhood is defined by identifying the amenities required in a certain radius and mode of transport. A computational model is devised to evaluate the city based on access to amenities, spatial qualities, and commutability. The process of grading shows the various stages of identifying the count and distance to amenities within varying radii to determine areas with least scores. Datasets sourced from government databases and other sources are arranged into three categories: demographic data, spatial quality data, and commutability data. Unsupervised algorithms such as PC and K-means clustering are used as machine learning tools to study the site of interest in detail. The sites are first defined by using spatial computational method to extract angular step depth and then analyzed based on the results from the machine learning tools. They are compared with respect to population density, income, employment, living environment quality, and accessibility. The comparison results in selection of sites situated in West London due to several factors. Angular step depth is used to create a detailed model defining the reach of a 15-minute city as an individual moves through. Factors such as rainfall runoff, contours, slope, terrain, and shadow help evaluate the geographical influences. Simulations are performed to examine the way that isowaves rays and sound propagate into the urban fabric. Semantic image segmentation is performed for each road segment using CNN. The data extracted is classified into categories of built spaces, people, and unbuilt spaces. Congestion, integration, noise, and air pollution on streets affect the living environment quality. The distribution of amenities varies as an individual moves along the street network. The areas for intervention are identified using cellular automata on a grid containing extracted datasets. An optimization algorithm is used to select segments with poor spatial qualities based on multi-objective approach. Then an agent-based simulation is conducted to further reduce the extent of the site. Buildings are selected and interconnected based on accessibility to amenities in their proximity. The 20 segments derived from spatial computational modeling are influenced through an isochronic generative loop created on the selected 4 segments, coupled with data extracted from traditional data analysis and deep learning networks. The strategy is proposed by evaluating the existing and using the theoretical background of a 15-minute city. A multi-objective optimization algorithm defines the placement of interventions based on elevated values of predefined attributes. The result is deconstructed to compare the disparity between each generation of every objective in order to be subcategorized into elevated, void, and mobile segments, which are interconnected by minimum angular steps between them. Elevated segments are located on junctions to reduce the time taken to travel, linking together the built environment while distancing the pedestrian from vehicular pollution and congestion. The segment design is obtained by iterating through forms to achieve maximum coverage, smallest shadow cast, and high visual connectivity. The form of the walkway in Harlesden is explored through a generative process using footprint and volume of the hypothetical cubes controlled by visibility and shading factors. The cubes are transformed into shortest paths from each end of the junction. The walkways are envisioned to change connections based on real-time GPS data and shadow casts throughout the day. Void segments are carved out between residential neighborhoods to encourage spaces for social interaction while altering the network centrality by reducing angular steps. The segment in East Acton is developed using spatial modeling process and data extracted from spatial computational techniques to introduce place-making elements along with interaction spaces and landscaping details. The process is applied to several segments located in Willesden, Harlesden, and Kilburn. Mobile segments are movable and temporary in nature and are located in areas with poor connectivity and accessibility to amenities to help build the economy by promoting local businesses. The intervention consists of units which are designed with adaptability and versatility to move on street network, rail network, and waterways. A steady-state island genetic algorithm is applied on site using the datasets of post-pandemic footfall trends. Several permutation and combination of the units are generated using an optimization algorithm to achieve the stated objectives. These modules are arranged on the site to serve as pop-up markets containing retail, recreation, commercial, and residential utilities. An application is created which allows users to analyze their neighborhood by locating the address and selecting a preferred mode of transport to receive a score for the area. The user can then design the nearest market. Various analysis layers can be studied to select an area for intervention. Utility modules can be added to the site by selecting a pixel from the predefined set. The application allows the user to experience their design through virtual reality. The proposed strategy, when applied to multiple high streets throughout the city, alters the physical and spatial characteristics, transforming London into an isochronic city.